we're going to focus on database technology. Most websites get their data from a back-end database. Of course, there are exceptions to every rule. You may have very special-purposed websites that, for example, generate their own data or use data that are not persisted. But think of any e-commerce site. There are products, vendors, orders, customers, on, all sorts of data sets, and those data sets typically are saved, persisted in a back-end database. It's fair to say, I think, that a website with a back-end database is the rule, not the exception. Now let's focus on the Java side. The Java side will become much clearer as we get into examples, and we'll do that in the next lesson, but for now, let's do a little bit of overview. Any Java app, including a web app, is going to talk to a database system through a so-called database driver, which is basically middleware. And that's typically delivered through a jar file. It might even be more than one jar file, but at least one jar file. The good news then is the Java app is insulated from the peculiarities of the database system because the Java talks to the driver and the driver talks to the database. So the good news is that if there's a driver, Java can talk to the appropriate database system. Now, Java's got a couple of different APIs. Sometimes these are described as supporting access patterns for talking to a database. There's the tried and true JDBC, officially no longer an acronym, but at one time, of course, it stood for Java Database Connectivity. This is relatively low level. It's close to the metal. You basically talk to the database through SQL statements, and we'll see that in the next example. The higher level API is JPA, the Java Persistence API. And you might say the way you talk to the database through JPA is in a native Java fashion. That is, you use constructors, you set properties, you get properties, that sort of thing. The SQL is typically under the hood. Java's JPA technology is basically its ORM technology, Object Relation Mapping. And this is very powerful, relatively easy to use because you don't have to get involved in SQL. It's also, for that reason, more portable. Some of these names you may have run into, for example, among the providers for JPA are Hibernate, easily, I think, the best known in the Java world, but there are others, including, for example, OpenAPA. One noticeable difference between JDBC and JPA is that in JDBC, you see the driver, in effect. You load it explicitly in your app. With JPA, by contrast, that sort of thing is really done in the background through configuration files, which is typical in Java, are XML files. And we'll see examples of all of that, so that will be fleshed out. Don't worry too much right now about the details. We're just trying to get an overview. So for us, the important thing is we can use JDBC, we can use JPA, and we'll use both. Now let me switch gears and talk about what database system to use. There are, of course, two broad types nowadays. There's relational, table-oriented, and there's non-relational, so-called NoSQL, which basically focuses on key value pairs that are persisted. Java is oriented in general towards relational database systems, but JPA in particular is sufficiently rich that it can support NoSQL database access as well. And I give an example basically of TopLink, which supports access to MongoDB, one of the better known NoSQL databases. We're going to use a relational database. Any one would do. So for example, if you're already using SQLite 3 or you're using MySQL or TopLink or anything else actually, if you have experience with those, you have a driver for those, I wouldn't change a thing. If you've not done anything with database, I would recommend PostgreSQL, which is what I'm going to use. It's really good. It is ready for prime time. It's production grade, industrial strength, however you'd like to describe it. The documentation over the years has gotten much, much better, and the installation has gotten to be much, much easier. If you're on a Mac or a Windows platform, it's basically a one-click installer. I've provided the URLs in this section. PostgreSQL also has extensions that cover, for example, NoSQL features. So I think it's an appropriate choice as a default. It's very powerful. It's what I'm going to use, but it's not what you have to use. So if you don't have anything installed right now, I strongly encourage you to go with PostgreSQL. But if you have something installed that's already up and working, a nice relational database management system, you can stick with it, and my examples should work with that as well.